Greetings, friends. In this little video, we want to talk about one of the more powerful statistical expressions called effect size. And when we're dealing with stats, one of the things that we know is that the statistic in and of itself doesn't mean very much. Where the statistic has power is in comparing it to other statistics. And then one way to describe the difference between two numbers in a statistical set is to talk about effect size. Now this particular expression can be used in a number of different ways, and we want to talk about how it can be used specifically with standard deviations. And in this week's work we've talked extensively about standard deviations. There's a lot more that can be said, but for now what we know about standard deviations is it's a way to describe the shape of a set of data. And so what we've said is the best way to visualize that is through this bell curve, mean score right here in the middle. Approximately 34% of the people, one standard deviation below the mean, 34%, one standard deviation above. Approximately 14% in that second standard deviation above or below the mean, 2% in the third standard deviation, and so on. In fact, you can get so refined where you can talk about less than 1%, 4, 5, and 6 standard deviations above and below the mean. But for our purposes, first 1, 2, and 3 standard deviations above and below the mean pretty much explains most of the individuals in a particular population set. And here another side, just summarizing what I just noted in the previous slide. If you can remember these numbers, 34%, 14, and 2, for the various number of folks who are in first, second, and third standard deviations above and below the mean. One of the ways that researchers talk about expressing standard deviation as a way that's helpful and meaningful is to talk about how much improvement relative to standard deviation a particular kind of an intervention might affect. So let's say, for example, that there were some kind of a standardized test, and the mean score of that set was 70 with a standard deviation of 10. And for our example here, 70 was the meets standard score. We would say that in this case, 50% of the students met the standard, and 50% of the students didn't meet the standard. So if we were just going to go ahead and graph it, it would look something like this. Here's the mean score 70, half the students did not meet the standard, half the students met the standard. For our example, what we want to do is see what the result would be if we did this particular intervention. We're calling it the ABC Enhancement Program, and it said that it would increase scores by 1 standard deviation. So the new program will move the mean to a score of 80, where 84% of the people will meet or exceed the standard and only 16% will fail. So let me show you what that looks like graphically. Here's the chart, and this is the distribution of students. 70 the mean score, half below, half above. What would happen if you moved the mean score by 1 standard deviation, improved it by 1 standard deviation? The new chart, or the new distribution, would look like this. So here's the old bell curve. Looks just like this. But here's the new bell curve after the intervention. Basically, we moved all the scores 1 standard deviation. This is standard deviation. 1 standard deviation to the right. Now, what's powerful about this is to see how much now of this bell curve and all the students that are represented by it, how much more of that curve now lies above the passing grade or the cut score or the proficiency score. If you were to add all these standard deviations up, 34, 34, 14, and 2, you would find now that 84% of this curve lies above the mean score or the passing score. the old mean score, which we determined was the cut score for the passing score. And only 16% are below. So saying that scores improve by 1 standard deviation is a way of saying that this is a powerful intervention now where 84% of the students are now above the old mean score. So you move from 50% above the mean now to 84% above the mean. Now, Robert Marzano has used this statistic extensively to describe the effects of certain kind of instructional strategies. Now, many of you may know his rather famous 9 instructional strategies, and this is the result of literally decades of research. And what he's identified is the effect size of various kind of instructional strategies. And if you're an educator, you probably know all these. Identifying similarities and differences, that's basically critical thinking skills. Instructional critical thinking skills have an effect size of 1.61, quite a powerful increase. Summarizing and note-taking is an effect size of 1, which is saying 1 standard deviation, and so on. Graphic organizers, a little bit less. Group work, cooperative learning, right in the middle of these. So for our purposes, it's very helpful to know this particular way of describing statistics. So what I want to do is go through some examples of how this might work if you were trying to make a case for advocating for a particular kind of an instructional strategy. If you're wanting to secure some additional training for your faculty, or trying to convince somebody that they should engage in this particular kind of instructional strategy. So let's take this one right here. The results of research suggest that instruction in summarizing and note-taking will result in an increased effect size of 1 standard deviation. If we go back to this chart, I'm pulling this right here. So again, just for sake of example, right now the average score in achievement test is 50. Standard deviation of 15. What would the new average score be in the assessment if the program is successfully implemented? Well, the way that we do that is we take what percentage of the standard deviation this particular intervention will increase, add it to the old mean, and get the new mean score. So the effect size is 1. Standard deviation is 15. So what percentage of that standard deviation would be experienced as an increase? Well, all of it, because the effect size is 1, same as a percentage of 100%. So we just multiply these two together, add to the old score, we get 65. So you'd be able to say, if we do the strategy, if our old score was this, and our new score would be that. Another example. This is the most powerful one, strategies in critical thinking, identifying similarities and differences. Again, just a randomized score of mean score of 72. Standard deviation is 8. What percentage of 8 would we experience as an improvement? Well, 161%, or 1.61 as a percent of increase. So we multiply this number times standard deviation, add it to the old mean. You come up with 84.88 would be the new mean score if you implemented this instructional strategy adequately, with adequate staff development and modeling, and it was done well. You would see a very powerful increase in whatever assessment that you were using that was related to the demonstration of critical thinking. And then one more here. Reinforcing effort and providing recognition. How much of an increase can you do if you were to engage your students and complimenting them, encouraging them to give their best effort and rewarding and recognizing that effort? Well, Marzano said you should see an effect size of 0.8, excuse me. So right now the average scores on this particular achievement tests are 90, standard deviation of 14. What percent of that standard deviation will this particular intervention increase our scores by? Well, 80%, or 0.8 should do the trick. effect size, standard deviation plus the old mean is the new mean. So 0.77 times 14 add to the old standard deviation is an increase of to a new mean score of 84.88. Now in Marzano's books, he gives more examples of how this might work. Other researchers have come up with other kinds of other studies that come up with different effect size. And you can see those listed here. In educational research, it's not unusual for one researcher to have a completely different result than others. So what Marzano does is he goes back and he, takes a number of effect sizes. So he will be referencing 31 studies here to come up with his average effect size. Setting objectives and providing feedback, he studied 408 studies to come up with this number here, which speaks to the whole idea of validity. So some other examples from his book, What Works in Schools, which I used this textbook right here, or this book right here for these examples. The importance of providing feedback, different types of learning experiences, verbal instruction, visual instruction. By the way, dramatic instruction always seems to have a greater effect size. And you can see that there is some longevity to this. Even after 6 months, these effect sizes remain in place. Well, we wanted to show you these so that you'd be able to have a better sense of how to read this material, and the activity for this week is based on understanding effect size and then being able to apply it.